Good afternoon, everyone.
So when I came to US, I was very new to English as well as American English. I used to write words like COLOUR for color as compared
Recording in progress.
Hello, Aruna?
Yes, madam.
Ah,
Madam, sir has already joined the session. Shall we start?
other participants to log in 2 minutes. You can start and you can start at your end recording also.
Okay, madam. Sir, good afternoon, sir.
Good afternoon. Here it's evening. Should I give host access to?
Yes, sir.
So I'll give host access to HOD ma'am and co-host. And who should I give the host access?
Well, you can give co-host to both of us so that we can record some output, right? Okay?
Okay. Yeah, I made co-host both of
Okay,
you,
thank
ma'am.
Thank you, sir.
I think we can start now.
Sir, sir, please, I request you to please start the session, sir.
Yeah. I hope my screen is visible, and I'll make sure that recording is on. Okay. And I'm just trying to make it full screen. Give me 1 second. I cannot do that. Okay. Let's just start with day 2 presentation. And I hope my voice is clear and my screen is visible. And if it is not, kindly let me know. Okay. So in the day 2 of the introduction to ML and DL, we'll start learning about artificial neural networks. And this is a ML algorithm, and later these algorithms started evolving, and an entire field of algorithms created, and we call that deep learning algorithms. So today's session will be of 3 hours, and in which like 1.5 hours will be the theory, and 1.5 hours will be 2 hours will be theory, and 1 hour will be the practical. And in the meantime, like I will stop in between the like sessions to ask for questions. So if you have any doubts or anything while I'm teaching, make sure to put it in the chat, and I will address it after one section is done. So I'll start by doing some recap of previous topics that I taught yesterday, and I'll share these slides as well. So this is just a formal write-up of the things that we discussed yesterday and discussed in detail yesterday with examples. So we started yesterday with machine learning. So we discussed that machine learning is a field of study that enables the computer to learn from data. So we had some so suppose earlier we used to have rule-based systems, and we then generated data, and using that historical data we try to automate a task, and we call that machine learning. And then we discussed about the features. The features are the individual variables that we saw yesterday, and uh, features can be like it sort of gives the properties about a thing, and features are the variables that are responsible for a class to be a class, or like a value to be a value in the labels column. So features are like uh, so they represent the measurable characteristics or properties of the data, and their values are used to make prediction for classification. And so we discussed there are two primary types of features, although there are a lot of type of features, but two primary types are like numerical features and categorical features. And we saw that in numerical features they're like house prices and distance to the school and all these things. And in the categorical feature, the categorical feature can be like sex of a person, like male or female, it is categorical. And the class of the ticket that the person has bought, is it like first class, second class, or third class? So apart from that, we learned about labels, and labels are the target variables, we can say, or the or the thing we want to predict or classify. In our example, the labels for the task number one was the price of the land that you were trying to predict, and in the second task, the the uh, in the second task the label was I guess uh, the survival the survival status of the travelers, if the survive the if they survived or not. And then we discussed about the data set, and we agreed that a data set is a collection of data samples, collection of features and labels, and when we combine that, we get that the data set. And apart from that, we also learned about three types of learning, like supervised, unsupervised, and reinforcement learning. So supervised learning are those kind of learning where there is a supervision and the model is trained on label data, but there is features and label as well. And then we discussed about the unsupervised learning, where we saw that the unsupervised learning is trained on unlabeled data, and it tries to find patterns and relationship between the data without any explicit guidance. Then we discussed about the reinforcement learning setting, where there is the agent who is interacting with the environment, and it learns completely from the feedback and reward or penalties that it receives from the environment, and it tries to maximize its reward. And in the discussion, we also saw how a lizard is sort of trying to find some insects to eat, but if he find the insects, it will be like giving him a reward. If he couldn't find the insect, it will be like, and goes to the bird where he will be eaten. It is kind of a penalty for him. So this is the, I guess, yeah. So there are some other types of learning also we discussed. One of them was self-supervised learning, and another was semi-supervised learning. So self-supervised learning, we discussed that when like the model learns a supervised task with the data itself without having a label, that is called self-supervision. And the semi-supervision, we have some data that is labeled and some data that is unlabeled. So that is called semi-supervised learning. So I guess, yeah, so this is the thing that we discussed yesterday. And so today, so this is the basics of ML that you need to know before starting with deep learning. So in machine learning, there are a lot of algorithms that there which were developed very early in the 90s, or in the late 90s, like descent trees and support vector basins and regressions uh, and all those algorithms, naive Bayes and everything. But in this workshop, like since there is a lot of focus in deep learning these recent days, I will start with the regression, and I will reframe the problem into a artificial neural network problem, and I will start with how to design an artificial neural network and how to code that in the PyTorch language. And PyTorch is a a programming framework. Python is the language, and PyTorch is a like library for coding neural networks. And it's a very well developed library. And recently, that is one of the biggest contributor to the deep learning papers or journal that is coming these days. So we'll also look at how we code all these things to get a good neural network for your task. So starting with, we'll start with like introduction to neural network now. And neural networks. So if you have any doubts regarding the yesterday's session, you can surely ask in the chat. I will take it up after some time. So we'll start with neural network. Uh, so neural networks is so the story behind neural network is that neural network is a way to imitate how humans are thinking. So suppose there is neural network, and yeah, suppose so. What happened is that the way humans think is like this. Let's try to draw something here. Yeah. So what happened is that so how human brain makes a decision. What human brains does is that so there are like neurons inside our body. So and all these are connected like this. So what happens is that when a signal is coming from one neuron, and there is another signal coming from another neuron, and if this signal crosses a threshold, it will be propagated forward, otherwise it will not be propagated forward. And here also same thing, like if a signal is will cross this threshold, it will propagate it forward or it will not be propagated forward. And accordingly, so what signal will go to this neuron will be decided by the threshold that is there in these two neurons. So if the threshold is higher and the signal is weak, it won't be propagated forward. If it is strong enough, it will be propagated forward. And similarly, billions of neuron get connected to till our brain. And so all this signal that is coming from all the parts of our body will activate at some point or deactivate at some point, and accordingly the strength of signal that will depend upon the neuron that is passing by in the path, and what is the threshold they have to pass the signal to the brain or not. And so neurons like neural pulses from all these points will come to the brain, and looking at the intensity of the brain, intensity of the signal, our brain makes a decision. So it's not exactly how it works, but the idea is that all these neural pulses travel through networks, neurons, which forms a network, and to travel the network, you have to be you have to cross the threshold that is there in the network, and that is called the forward propagation, or the way the signal travels in the neural network. So based on that concept, the study of neural network has evolved till date, and people have started creating much bigger neural networks now, and which is so huge that it required very powerful computer to compute, and very powerful computer to compute and run those models. So in simple words, we can say neural networks are computational models inspired by the human brain structure and functionality, and they consist of interconnected artificial neurons, also known as nodes, that process the information. And these networks are capable of learning from data and making prediction or decision based on the pattern. So we'll go back to our this sheet, and we'll start with our example on the neural network. So if you recall, yesterday we talked about this X and Y pair. So if X is 2, Y is 4, if X is 2, let's say Y is X is 2, Y is 6, X is 3, Y is 11, and X is 4, Y is 18. So it's your task to look at. So if you recall the terminologies, this is my feature, this is my level, and this entire thing is my data set. Okay, and if I want to make any prediction, so if I want to make any prediction, suppose tomorrow someone will come and say, what will be the corresponding Y for 5? So as a human, how do I go about it? What I do is that I try to find the pattern connection between these two, and these two, and accordingly I will once I find the pattern, I will like find the corresponding value of 5. But as a machine, so humans just think, and we don't know how we think, but the machine level approximation of this thing is so what we think is, so how we do is that we sort of try to, okay, let's change this a bit for easier. I think I gave permission to. Yeah. Yeah. So now let's say this is the this is the pattern that we see. And let's say as a machine, we were like we try to recreate the same. And so we don't know what's the relationship between this. So we say that uh, there is a y, and y is some function of x. We don't know the function. We say that y is some function of x. And the whole idea of machine learning is that we try to approximate this function. So given this data, we try to approximate this function, and we try to find the actual function that is lying behind. And once we find the function, let's say this function is found, and I can just put any value v, and I will get the corresponding result. So the entire task is to uh, 1 second. Waiting. So I can find this. So the main idea is that let's say we have these pairs 2, 6, 3, 8, and 4, 10, and we are asked that sir, explain more about threshold. Yeah, so I'll talk about that while explaining this. Let's say so what I was trying to tell is that let's say we have this data pairs like x and y, 2, 6, 3, 8, and 4, 10, and you're given a task to find what is the value corresponding value of y for x. So what you say that let's say the value of y that is there, let's say the value of y that is there equal to fx, and y is some function of x. I don't know the function, but I know y is some function of x, and I am assuming that if I ever be able to find this value of fx in my lifetime, I will be able to solve this question. And machine learning says that the machine learning is a study of taking this historical data. So these are the historical data, and finding the function. And as people started searching, they found that it's very hard to get the exact function that the underlying data captures. So what they came up with is that so will not will not get the exact function, but what we can do instead is that we can always approximate the function, and we can always closely approximate the function. By approximating the function is what I mean is that let's say there is a function like this, and we can if we maybe we cannot find the exact function that represent, but we can always approximate that, which will be similar to the function that we that is there in the underlying data. So our task now has changed from guessing what is the value of 5 to finding the value of function fx. So what as a human if you look clearly, the answer for 5 would be 12. So answer for 5 would be 12. And if you are like clever enough, you can must have figured out that y equals to 2x plus 2. And if you plug any value here of x, you will get the corresponding y. So if you put 2, you will get 6. If you put 3, you will get 8, and so on. But the problem with machine is that machine don't know this 2 and 2. So what as a machine, what we'll assume? We'll assume that we don't know the this value of 2, so we'll assume that let's say y equals to x into something, some a plus b. So we'll assume like this. So we don't know what exactly is a and b, but we'll assume like this. So I think you are with me on this. So actually, like from this point, I'll be starting the the base for neural network. So when I ask like, did you get this? If you don't, just tell me in the chat. I'll reiterate the same, because from this point only we will start exploring to the neural network. So till this point, if you're clear, just you can type yes in the chat, so that I will know that you're clear, or I don't need to explain again. It's just just the basics thing. Like after that point, I will be doing. Okay, I got one yes. Yeah, I guess everyone is getting till this point. So we don't know this 2 plus 2. So that's why we are assuming that, okay, let's say there exists a and b that will serve my purpose. But the problem now came from guessing what is the value of 5 to guessing the value of a and b. So if you are a kid, so what we do is that we try values. So we try values. So we can try for so if I take a and b, we can try values such as 1 and 1, then 1 and 2, then 2 and 1, then 2 and 2. So after trying these three values, you will get this as correct, and your function will be like, you'll find this function very easily. Yes or no? But if you see, this is very easy to find. But let's say instead of y equals to 2x plus 2, if y equals to 100x plus 1000. So in this case, it is very hard to find this two value 100 and 1000, because if you go by brute force method, if you try these values one by one after another, it will be very hard to reach this value. And imagine if these values are in millions, in 10 to the power 10 x plus 10 to the power 10. So it will be very hard for you to go one by one and try this out, and reach at this point where you'll be able to find this function. So so you can now agree that we need a more intelligent way of picking of values for a and b while approximating a function. Yeah. Okay. So now you get that, just by guessing all the possible values is not a good idea. So brute forcing is not a good method. So it's like linear searching. So you are searching through the possible values linearly, starting from 0 till you get the value. So second way of guessing these values is random guessing. In random guessing, you choose the value of a and b randomly. So what you do is that you choose so in the random guessing, the first value you choose maybe 1 and 1, second value will be 5 and 10, third value will be like 100 and 10 to the power 10, and so on. So you randomly pick values and you try, and you try to find what function is this. So remember the story that you are like that I told in the told initially. So what the task that you are trying to do is that we are trying to approximate this y, and we don't know why the function fx. We are saying that this function is some a into x plus b, and we're trying to we're looking for an efficient way to find this a and b. So the more quicker, the better it is. Initially, we started with this linear, like where we guessed all these values, one after one, and the second way is like second way is saying that we'll guess randomly till we find that. And experimentally, people have found that if you guess randomly, you'll get the appropriate value of a and b faster than if you search it linearly, starting from 1 to 1,000. But again, like, so I guess like I bet more than 80% of the students must have gone this must have found this 2x plus 2 just by looking at these three values. 2 is 6, 3 is 8, and 4 and 4 is 10. Then 5 will be 12. You must have got these values very fast. But so do you think, like, spending, like, all this amount of time searching randomly is a good idea for me to just guess this value 5 to 12? No, this is not a good idea. But so how can we, like, improve this? How can we find this missing values? But third way of dealing, and it is the current way of dealing, is called gradient descent. And the gradient descent way of saying is that we don't pick the values that we randomly or sequentially. So what we will do is that we'll pick one value randomly, first value randomly, then we will evaluate our choice. If the value we picked is a better value or a worse value, or and should I go up from the random value or should I go down from the random value to get my appropriate A and B very fast? That means, so if I guessed my first value to be 1 and 2, the next value I will be guessing will depend on the success of this value. It will evaluate the function, evaluate the success that I got from this value, and depending on that, it will decide, should I increase this to value or should I decrease this to value, or should I make an increment in 1 and decrement in 2, or a decremented 1 increment in 2. So by evaluating this, it might come up with 1.5 and 2, and third values can be like 1.7 and 2, and fourth value will be 2 and 2. In just 4 steps, you'll get this value 2 and 2, but while others will take like a hell lot of time. And this is like a special case where the sequential value meets with a gradient descent one. But uh, theoretically, if you say, if you look into a large number of data set, this gradient descent is much faster than this sequential guessing. And this is the idea behind gradient descent, where we choose the value, the next guessing, based on the success of the first guessing. And how we choose, how we evaluate, and how we come up with the next new value set pair is a something we will study in the gradient descent, how it is done. And okay, and yeah, so gradient descent is and the so there are the three way of guessing this thing. So if I like start to look it formally and write it formally. So if I start to write it formally for neural network, so what we did is that, so we have this initial value 3 is 2, yeah. So this is initially 2. We multiplied it with A. We got 2A. Then we add B. We got 2A plus B, that is equal to Y. So initially what we did is, so this is a single layer neural network. So this is a 2-layer neural network. This is my input layer. This is my hidden layer. This is my output layer. So here, like it's the simplest neural network, and sorry, it's just a 1-layer neural network, and this is not an output layer. Sorry, this is not an output layer. So this is not an output layer. This is the hidden layer as well as the output layer for this case, and it is just a 1-layer neural network, and one node is there, and this is so these are called nodes. And these are called weights, and the thing we're adding is called bias, and the thing you are getting is called output. Lots of terminology for a new, if someone is doing ML and DL for the first time. So these are the terminology you should care about, and this weights and bias are called parameters. Yesterday someone was asking if feature is same as parameters. No, features are not same as parameters. This two is features, input or features. The thing we multiply or the thing we add to this input, so that all the thing that we add or multiply to this input features is called parameters. And we, by in the neural network, in the deep learning, we try to estimate these parameters, and which is called parameter estimation. And by estimating this parameter, we'll try to approximate the function fx equals to y. And this is the basic idea behind a neural network. And now I'll start to show you like how this how I can use this simple neural network to predict the value of 5 that is there, and how this value of a and b will be calculated in the next steps. So so these are just terminologies. You should go through them once or twice to get this. So starting with round 1. Round 1 is called, there is a terminology for that. It's called forward. No, round 1 is weight initialization. I would say parameter initialization. So in the parameter initialization step, so we have two parameters, one weight and one bias. The weight is A and bias is B. So we will initialize it. Like initialize is, this means like we'll assign some value, some random value to it. And for our simplicity, we will assign A as 1.0 and B as 1.0 as well. So we'll initialize this like this. So we need some initial guessing. So initial random initialization we need to do. So there are a lot of type of initialization as well. But for now, we'll do random initialization, and randomly we picked one and one for A and B. You can also assign 0 for it, but 0 is not a good thing to initially choose. It will not converge easily. Then comes to round 2. Round 2 is called forward propagation. Forward propagation. In this forward propagation, what we will do is that we will do this operation and get the output. So my y is equals to ax plus b, which is equals to a is 1, x is 2, I guess. Yeah. Plus 1, b is 1, which is 3. So this is y hat. I'll put a hat here to represent the my predicted y. So this y we called predicted, and we denote it as y cat. So now, so this you know earlier. So now if you see, this is 3, but what is the value that we have for 2? So I'll just copy paste this for you to refer. I'll copy paste here. I'll just write it again. Yep. So now you can say the value corresponding to is 6, but we predicted 3. So this is wrong. We know that wrong, but how much is this wrong? So we'll so we know that we missed, but how much did we miss? So we called it the loss, or you can call it as, you can call error or loss. Loss equals to actual y minus the predicted y, which you get as 6 minus 3 equals to 3. Actual value is 6, you got 3, and you subtracted that, you get 3. And this is the loss. Okay, so I should be like keeping this in a different section. Let me select this. Okay, so erase it. Yeah. We'll go to round 3, which is error calculation. In the round 3, we sort of find like how much did we miss? Error or loss equals to y minus y hat, which is 6 minus 3 equals to 3. Then the next step is round 4 is back propagation. And back propagation is something that we will learn. And so this is the thing. This is the area. This is a point where we will go a bit into depth. And so round 5 will be just updating the weights and updating A and B. So it's like getting the second round of A and B for our prediction. So so this is a very important concept in artificial neural network, is the concept of back propagation. And everyone should very carefully understand this, because this decides what is the value of A and B in the next iteration. So in the first iteration, we decided on 1 and 2, and we saw that 1 and 2 are not very good at predicting our function y. So we saw that it is lacking by factor of 3, which is a 50%, which is deviating by 50%. So what we will do is that we will try to adjust the value of A and B so that it can come closer to 6. So by back propagation, that's what I mean is that, so let's say this is let's say this is the curve that represents the error or the loss. Let's say this is the curve that represents the loss, and let's say this. So this is the point. So this is 0. This is some value n. So this is the point where your loss is 0. So this is the point where your loss is 0, and this point is A. So in the x-axis, you have the value of A, and it is the loss. Let's say this point is K, and you want to find K, and you are not at K now. So you are at somewhere here. So this assumption of, so not here, you're somewhere here, because you assume that the A to be 1. Okay. So you assume A to be 1, and for A to be 1, the value of loss is 3. Value of error is 3. For A to be 1, the value of error is 3. And you know that if you go in this direction, one step at a time, you will reach here at this point K. And if you go in this direction, your loss will increase. So let's say if I change value of A to 0.5, it's like moving in this direction, like reducing the value. The value is now 0.5. And if you calculate, if you calculate clearly, you can see that this value is 0.5 into 2, which is 1 plus 1 equal to 2, and the corresponding error is 6 minus 2 equals to 4. For 0.5, the error value will be somewhere near here, and it will be 4. And it is like increasing. So you want to decrease the error. So you need to go in this direction. So now, like when you are calculating, you don't know which direction to go. You just know that I will go in a direction where the loss is getting decreased, or the loss goes to 0, or the loss at least minimizes. Go to the you need to find the minima in this curve. You need to find the point where the loss is 0 or minimum. So to obtain that, one so you don't have this curve with you. It just a way I represent here. So if what you have is just this one. So from this, you need to come up with something so that you can move in this direction and finally meet k where the value is 0. So to do that, one way is that one way of dealing with is that, so they say that travel in the opposite direction of gradient. By what I mean traveling in the opposite direction of gradient is that, so let's say gradient is the slope. So at this point, this is the gradient, this is the slope of this curve, and if you know this is negative, since this is negative, you need to travel in the positive direction. And if you were here, let's say you are at 6, so the slope is positive, slope is the tan theta, and it is positive, slope is positive, and you need to travel in the opposite direction of the gradient, which is in this direction. So from this, you got to know that the direction you will be traveling should be in the opposite, means negative direction of gradient of loss, or you can name it as minus dl by dx dA, because you are differentiating with respect to a. So slope of this loss with respect to a is the minus dl by dA. So now you know like which direction to move. So which direction by like direction, what I meant is that, do we need to increase a or decrease a? So we saw that if I am decreasing a to 0.5, the loss is increasing. So I need to increase a such that the loss will decrease. So if I go to a equal to 1.5, the loss will be 2, because 1.5 times 2 is 3, plus 1 is 4, and you will get 6 minus 4 equals to 2. So the loss is decreasing. So here the decision is that, should you increase a or decrease a, or should you go in? So that will be defined by traveling in the direction of gradient or away from the direction of the gradient. So we saw that if you travel in the opposite direction of the gradient, like if it is negative, we travel in the positive direction, and if it is positive, we travel in the opposite direction. We are sort of going towards the minimum point. So our goal is that if we are somewhere here and here, we'll be always going to the minimum point. Like if you travel in this direction, here the value is like this, here the value is this. If you come to this point, value is 0. Here it is still minimum, like you still some travel to go. So if you are here, you travel this direction, and if you are here, travel this direction and this direction. So this is the way, like you decide which direction to travel in the in this error curve. And second thing is that how much to travel. So how much to travel is also important, because let's say this is the error curve that you have with L, A, and loss, and you are here, and you found the gradient, you saw that it is negative, and you should travel in the positive direction. If you travel a little, if you travel very little, you will be again here, you'll be again measure the gradient, then they'll again travel a little bit, and but for reaching here, it will take a hell lot of time for reaching here. That is problem number one. If you traveled very less, so what will happen if you traveled? What will happen if you travel larger distance? So let's say you are here and you figure out that you need to travel in this direction, and you take a very long step and you reached here. So this is the value of A in the x-axis and is the loss. And when you reached here at this point, again your loss is same as what it was previously. Some value L. It is same. It is not reducing at all because you skipped the minimum. So this is the minimum point where the value is minimum 0, and you skipped this part to jump to the opposite end where the value of loss is again the same as the value of loss it used to be in this side. So you shouldn't take a very large step, or you shouldn't take a very small step. What should you do? You should take just the right step. So if you take step this big, you will reach here. And if you take again this step, you will reach here in just 2 steps. And this is what you need. And the factor by which you move in an error curve is called learning rate, and that will defined by alpha. Yeah. So how do we know how much to move? So so the question is how do we know how much to move? So this is the alpha, and this is called something as hyperparameter. So our A and B were parameters, and alpha is hyperparameter. And hyperparameter is something that we humans decide while guessing the value of A and B. So this is a completely depends upon you how much you wanna move. So the best way you can do is that you can choose a random alpha and check if you're converging very fast or very slow. If you're converging very fast, then you need to reduce the alpha. If you're converging very slow, you need to increase the alpha. So what happens is that you take a bigger step, you reached here, then you again take a bigger step, you'll end up here. So you just oscillate between these 2 points, minima. That is called oscillatory motion, where you oscillate around the minima but you do not reach there. So in this type of setting, you need to reduce the step size so that you will reach there very smoothly. And in this type of setting, you need to increase the step size so that you will reach here very soon. And so this alpha will not be same in all the iteration. You need to update that according to your result that you are getting, because this loss curve will not always be this nice. This can be something like this as well. So if you are starting from here, if you take smaller step, it will be very time consuming to get here. The minima, the point where the loss is minimum, this is A, this is L. And something like this also happens where the curve is very sharp like this, and you are here, and you take a small step and you are so if you take one step, you will be here. If you take one more step, you will be crossing the minima. So it is very hard to getting to this minima in this setting. So you also need to take care of that by adjusting the step size or alpha that I said. Step size, alpha, or learning rate is the same thing, that we just use it interchangeably. So this is and also there can be a scenario where the curve can be like this, and you start from this point. And when you start from this point, you will always go to this point, and you will never reach here. And to get the minimum loss, you need to reach here. You need to find the value of A, which give you the minimum loss, and you will always stop here, because the moment you try to go this direction, you will find that the gradient is negative, and you will travel in this direction, and you will end up here. And if you travel in this direction, the gradient will be positive, and you will end up coming back to this point. So for this case, what people do is that they try to start from 5 different points. They start from here, they start from here, they start from here, they start from here, and they start from here, and they will choose the value which gives them the minimum loss. So here we started with 1 and 1. You might start with 0.5 and 1, and you might start with 0.7 and 1. So there's like different way of starting values to get the minimum values while finding, because this kind of scenario might come. And if this is the scenario, if you have chose a value which is starting from this point, you will never come here for the minimum loss. And since you know, how much to move, since now you know how much to move and which direction to move, you can easily get your next set of A. So that will be like A new equals to A old minus D of loss with respect to D of A into alpha. And if I choose the alpha as 0.1, and as I said, alpha is a hyperparameter and I can choose anything, I will get A old is 1 minus the loss is y hat minus y by dA into 0.1, and it is 1 minus, and you know that y hat is A into 2 plus B minus y by dA into 0.1. And if you differentiate this, you'll get 1 minus. So this dA by 2A will be 2. dA 2, and this will be 0. This will be 0 into 0.1. Yeah, this will be there will be 1 minus. So the formula is A new equals to A old minus of this. So there will be another minus here, and I guess I'm doing right. So 1 plus, it will be 0.1 of 2, and it will be 1.2. The value will be 1.2. The A new will be 1.2. Similarly, you can find the B new as well. And if you find the B new, you will get if you find B new, you'll yeah. if you find B new, it will come around. So here instead of dA, it will be dl by dB, and it will come around 1.1. If you calculate it, it will come around 1.1, and this will be the new A new and B new. And from here, you will start the iteration 2. From here, you will start iteration 2, and iteration 2, your value of A is 1.2, B is 1.1, and if you find the value of y hat, it will be 1.2 into 2 plus 1.1, which is 2.4 plus 1.1 is 3.5. And if you find the error, loss equals to y minus y hat, that is 6 minus 3.5 equals to 2.5. And if you mark this, 2.5 is less than 3. So now you can claim that the decision you took for increasing the value of A and B is right, it's correct. So the second, so unlike this method, where your second guess is just random, or the second guess do not increase your possibility to find the target function, or the second guess do not actually reduces your loss. This one actually like reduce your loss, and this one reduce the loss by 0.5. So you can say that this value of A and B after one iteration is a bit more beautiful than we had earlier, the value of 1 and 1. And if you continue this for more number of iteration, and for the iteration 2, you don't need to choose the value of x as 2 now. You can choose the value of x as 3 now. So 1.2 into 3 plus 1.1 will be like 3.6 plus 1.1, that is around 4.7. And also you can see that the error that you used to have earlier is reduced now, because with value 1 and 1 you must be getting like 4. So now you're getting 4.7, which is better, because value of 3 corresponding was 8. So there is a difference of 4. Now it is reduced to a difference of 3.3 only. So in this way, if you do multiple iterations, you can reach the optimal value of A and B, which is 2 and 2. So this is the basic algorithm of neural network, the backpropagation algorithm, and using which even if today also all the big neural networks are updated using this principle only. Just the number of neurons will change, and the everything will be same. Like instead of x, now you have x1 and x2. Instead of A, you have W1 and W2, and you are getting some value here that is called, let's say, Z, and Z equals to W1 x1 plus W2 x2, and then you add some bias to it, you get y hat, and y hat is equals to W1 x1 plus W2 x2 plus B. And if you think carefully, now the loss curve is not a 2D curve anymore, it's a 3D curve, and this x-axis is W1, y-axis is W2, and this z-axis is loss. So in this way, you can increase this value to x1, x2, x3, and you can also again add more layers in between, so that x1, x2, x3 will go to z1, z2, z3, and this z1, z2, z3 will again go to O1, O2, and O3, which is the output layer. So in this way, you can increase the complexity and you can increase the number of neurons that is there in the initial layer. You can add more layers. You can set the output layer according to you, and accordingly you will get a network of neurons which is called neural network. And all these things will combinedly give you a will like so you will initially will assume values for this, some random values, and you will predict something. From the prediction you will update this value of w1 and w2 in the round 2 and this bias as well, and then they will again go through this exercise, and after like set 10-15 iterations you will be able to accurately guess, or even if not if it is not accurately, you will guess very close values to w1 and w2 and b, and you will be able to predict this function fx equals to y very efficiently. So this is the idea behind neural network. So I'll just look into the questions that you have in the chat. Yeah, one question is that, but sir, how much? Okay, so there is, can anyone share the attendance link? So I guess like I don't have the link for attendance or something. And next question is that, but how will we know how much to move by, sir? Like how big of a step? So Satvik, like I already mentioned here, this you need to move by the step of alpha. So if you find, so in iteration 1 you find a new a and b, in iteration 2 you find a new set of a and b. Let's for example, after the iteration 1 you found a and b as this 1.21 1.1. Let's say after iteration 2 you find a and b value as 1.25 and b value as 1.15. So this is not a great improvement. So you should be looking at a equals to 1.3 at least, and b equals to 1.5 at least. So this is an improvement from the previous value. This is a better improvement than the previous value. And if you are not sort of getting this improvement, what you can do is that in this step you can change this value of 0.1 to 0.5 for the iteration 2, such that you will get better steps, because here if the value is 0.1 you are getting 0.2. If it was 0.5 you would have got 1 here, sorry, not here, you would have got 1 here, and you would have got a new equals to 2, which is our target value. So the value of hyperparameter depends on the user and how he sets that. So if you could find the perfect value for hyperparameter, you will go to your minima in just one iteration as well. Okay, then next question is from Yosita. How do we know the shape of the curve? So you will never know the shape of the curve. So that's why if you know the shape of the curve, you can just say that, okay, I am standing here, I will go in this direction. So let's just let's think shape of the curve. How do you get the shape of the curve? So this is a curve between A and L. This is a curve between A and L. So A, so you for one A equals to 1, and some B, let's say B, some random B, you'll getting one value. Then for A equals to 2 and some B, you're getting some other value. So if you if you take value of A from 1 to 1000 and find the corresponding loss, you'll be able to plot this curve. Value of A will be from 1 to 1000, and this is the value of loss. Isn't it the same as sequential guessing that I did here? Just guessed each and every number till you find the solution. So this is the same thing. So that's why we don't have the curve with us. We just know that if we assume some value of A, we are somewhere in this curve, here or here or here. That's why we're assuming that we're somewhere in the curve and we're trying to move in the direction where the loss is getting minimized. So if we start finding the value of loss for all these values, then it will be very late when we find this minimum point. So that's why we just assuming that there is exist a curve, and we're assuming that we're at some point of the curve and we have to go to the other point of the curve where the amount of loss is 0 or minimum. I hope I cleared your doubt, Yoshika. Then next question is this: what is the definition of alpha and minus dl by dA? So definition of alpha is a learning rate. Alpha is saying like what is the amount of step we'll move in this setting, what is the amount of step we'll move. And so like in simple terms, so what is the amount I will increase or decrease from A. And the definition of minus dl by dA is what is the direction I will move, or should I reduce or increase the value of A. So to change A, so if let's say I'm changing value of A to some A dash, I need to decide two things. First thing is that how much. Second thing is that which way. Like if I want to change one and I need to subtract it, then A dash equals to A minus 1. If I want to change like value of 2 and I want to add it, A dash equals to A plus 2. So this is the two thing we need to decide. This alpha is how much to go, and minus dl by dA is which way to go. So sort of like that. Like in minus dl by dA, you will get a value, and by alpha you are just cutting that value to some percentage of that to go in this direction. Sir, how do we update the value of bias? So the same way you did here for the value of A, for the bias, the formula will be B new equals to B old minus DL by DB into alpha. The only change that we did here is the instead of DA, we're now finding DB. So for this, we're considering the curve between D and loss, the B and loss, bias and loss. So this DL by DB represents the curve. So you must have, if you recall, you can recall that the curve, the slope of a function is decided by d of y by d of x, since y is here L and the y-axis is here is L and x-axis is B, it is dl by dB. This will give you the slope of the curve at some point. So how do we evaluate bias? So I just mentioned bias. Is it always positive or negative? Bias can be positive, negative, or 0. So it's just a way to add this value. It's just we're just adding or subtracting. You can start the bias with 1 or 0 or randomly by any value. It will update with time to go to its optimal value. In this case, the optimal value is 2. For other cases, the optimal value can be -2, -3, or 0 as well. What is the value of dA when finding the alpha value? What is the value of dA when finding the alpha value? I didn't get this question actually. If you could ask it rephrase this. What is the value of dA when finding the alpha value? So you are not finding the alpha value, you are setting the alpha value. We are finding the value of A, not value of alpha. So you need to set the value of alpha, as something 0.1, 0.5, or 0.6. It's generally between 0 and 1, where you decide what portion of dA by dL you want to keep, dL by dA you want to keep. So if it is 0.2, you want to keep 20% of the value that you are getting from dL by dA. And dA don't have any value. dA by dL is evaluated at the, it's like this. dA by dL evaluated at A equals to A old, like this. Okay, so I guess this is all the questions that I got till now. So I guess this is the introduction to deep learning, and this is the way like neural network operates. This is the way we update things, and we get the next set of values, and we start by adding these values and obtaining this to get our final output. So if I just move forward with our discussion, what is wrong with this? What is wrong with this method? So this is pretty simple method. We assume a value of A, then we change the value. So we assume A, then we change the value of A, and while changing the value, we decide on two things: how much to change, which direction to change. So after deciding this, we get a value of A new. Similarly, we get the value of B new, and we go on to find the A optimal and B optimal. And in this way, we can guess our function fx equals to 2A plus B, which is 2 into 2 plus 2. Sorry, it's ax plus B. It is 2x plus 2. So this is like guessing our function in this way. But what is wrong with this method? What is wrong with this method? If someone can tell me. So there is something missing as well. Can you show the calculation paste for 1 minute to note it down? So I'll share these notes with you. Then you can refer to the note as well. So you don't need to take any notes. I'll share these things, all these things with you, so that you can refer it as and when you wish. Yesterday, that let's say I have passenger ID, then
Recording in progress.
to one neuron, and we can just put W1, W2, W3, W4, W5, and W6. Here we are adding a B, and we're in the output we are getting Z. And if you write Z is W1, and let's say I call it X1, X2, X3, X4, X5, and X6 is W1 X1 plus W2 X2 plus W3 X3 up to W6 X6 plus B, or in other words, Z equals to summation of I equals to 1 to 6 Xi Wi whole plus B. So what I can, so this is like, this is deciding the, this is like saying a person is alive or dead will depend things by how much, like how much should I care about the passenger ID while deciding a person is alive or dead? How much should I depend on this, the level he was on for it to assume it is alive and dead? So I denote them as weights. How much weight or how many weightage I should give to all these features. And since I don't know the weight, what I will do is that I will assume something like, for W1, W2, W3, W2, W4, and W5 and W6, and I will also assume something for B, and I will make a prediction. And of course, since I assumed it randomly, the weightage, it will not be the same for not be the actual weightage that that is there underlying the data. So my assumption or my random initialization will deviate by a lot from the target value. So what I will do is that I will take that error as a lesson, take that loss, and then I will back propagate that loss through the gradient descent to update this value of W1 to W6 to get the next round of W1 to W6. And again, I will make the prediction, and again, there will be some error. Again, I need to update this W1 to W6 to get my exact, and I will do this till I see my error is not changing or it has come to a very low value. So it's not, we should never wait for error to be 0. It will never happen. If the error is starting from, like, let's say 100, and if it's coming down to 2 or 3, or let's say 5, we can stop because we have reduced the error from 100 to 5. If we cannot predict these things exactly, we can at least predict these things approximately with very little amount of error, 2 to 3% amount of error, which is fine for time being. So this is the idea behind the neural network that I discussed earlier. Is just the number of variables as the input has increased, and hence the complexity. But if I come back to my question, what was if I come back to my question, like, what's the problem with this method, and why this will not work in many cases? Someone said that if the function has too many variables, it will take a lot of time to predict the values. So it will not take a lot of time to predict the values because all these W1, W2, W. So you see this A new and B new, it's not calculated independently. What happened is that, so under the hood, so what I did is that I can say that, so I'll just go a little bit deeper now. I can rewrite this as, I can say that my W is a matrix of W1 to W6, and my X is also a matrix of also a row matrix of X1 to X6. Then my Z is just a multiplication of X and W, and this is just a one O of one operation. This is a O of one operation, where you can multiply W1 to W1 W1 to W6 with X1 to X6 in just one iteration. So what I'm trying to say is that A new and B new can be computed parallelly. So even if you get, like, thousands of weights, you can compute them parallelly by just multiplying it and by just updating it parallelly. So the parallel updation will be like W new would be equals to W old. So W old is entire matrix minus the gradient. So actually, when you write in terms of one variable, you put d L by dx, but when you talk in terms of like matrix, you talk in terms of gradient, and the symbol is like this: gradient of loss with respect to W into alpha. So this is the way like you should now like do the notation. And if you look into this, this is like straightforward, and you won't need a lot of time if the number of variable increases. So yeah, so next solution I got is that we cannot represent exactly relation between the input variables and the outputs. Yeah, so the problem that we'll face is that when we'll come to, so these are all linear functions. If you say w1 x1 plus w2 x2 up to w6 x6 is linear function. So our function was f equals to 2x plus 2. Since this function was linear, it is very easy to compute. If the function is, let's say, f equals to x square plus 2, or like 2x square plus 3x cube plus 7, or even complex sin x plus e to the power minus tan x. So if you look at this function, you can never, like you can never represent this one with x1 w1 plus x2 w2 up to xn wn plus b. So you can never represent like this. One other way to go is that you can always x1 w1 plus x1 square w2. Similarly, you can x1 q w3. You can do this, but this will also not be effective, because if there is sin x, tan x, e to the power x, and many more, there are a lot of functions. Step function is there, direct delta function is there. If the underlying function is very tough, so think of function as the way you make decision. Suppose you are crossing a street and you hear some sound of vehicle, or you see a light, you don't cross. So the decision that you took is also a function. Given these two variables, light and sound, the so the prediction is to cross or not cross. It is also a function. But if you think about that, there is no exact representation of this function. You cannot you know take pen and paper and write sort of what function this is, but you can always approximate a function. So if you remember, you know that any function f can be approximated, or can be approximated using Taylor series, or you can show this as a sum of two sinusoidal curves, which is the Fourier expansion. But these are all very computationally expensive things to do. That is why we're doing neural network, where we approximate these functions very efficiently by deciding on some parameters. So I'll now show you a way where you can approximate these and this very efficiently using our this neural network, but making a little bit of change in this. So everything else will stay the same. I'll make just one change to it, and you will be able to approximate these functions as well, this x square and sin x as well. Okay. Give me 1 second. Yeah. So this is the way you sort of like so there's a way you sort of find these functions as well. So this is so so I now I'll introduce you to the uh, activation functions. Yeah. So when you like sort of find this z, which is equals to summation of I equals to 1 to summation of I equals to 1 to um, I to 6 xi wi plus 3. So what you need to do is now y hat equals to sigma of z, and this sigma of z and sigma is called the non-linearity. And this sigma is a non-linear function that you add on top of this linear function. So what you say is that I don't know what is the non-linear function that is there in this underlying function is in the underlying function. So what you care about is that you just add a non-linear layer on top of this linear layer, so that in a hope that it will predict these functions correctly. So if you like look into the examples of this nonlinear function, one will be like sigmoid, one is tan h, and one is softmax, and the last one and most important one is ReLU. So I'll discuss these activation functions one by one, like what is sigmoid, what is tan h, what is softmax, and what is ReLU. But before that, I should let you know that okay. So I should let you know that this activation functions or the non-linearity we add on top of this linear layer, such that this linear layer will behave as non-linear, and they will able to predict the functions that is non-linear to them, because as I mentioned a while before, in real world the functions are not linear. So it's not like that there is a light and there is a sound, and like if the light amount is this and light sound amount is this, then suppose there is a then I can assume that there is a car. It is very non-linear and it is very hard to predict. So that's why what you do is that we just assume that all the underlying function is linear. Then we just add a non-linear layer on top of that, with a hope that it will predict. It will approximate. It will not correctly if I add this network will not correctly represent sin x plus e to the minus tan x, or 2x square plus 3x square plus 7. But it will approximate this value. It will approximate this value to the correct to correct to some decimal point, or correct to some value, where if you put the value of x, so it's like if the true function is f of x, we're sort of finding a surrogate function f f n of x, where f n of x at any value of x is similar to f of x at that value of x. So this is our goal. Our goal is now not to exactly find the function. Now the goal is that we have to find a function such that if I put that value inside the new function, and if I put my value inside the value of x inside my old function, that should be closely related, and that should be very near about. It should not fail to approximate this function. So now we'll learn about different activation functions that is there, and what is the type of nonlinearity that we put on top of these functions to approximate very complex functions that is there in the mathematics, in the entire mathematics. So these 4 nonlinearity can be used to approximate anything that is there in the mathematics. And why they can do, there's a nice proof of that as well, like why using sigmoid will approximate any function that is there in the underlying data. So there's so it's a very nice proof is there. I can share it later, where you can see all this how sigmoid is building all this small curves, and this small curve is able to approximate any function.